Hey everybody, welcome to today's Getting Started with Kubernetes and Rancher online training. Really excited to have everyone join the call. We have a ton of people today and excited to take you through the training that we have prepared. This session is being recorded, so if you miss something, if you have to step away for a moment, don't worry about it. You will get the recording, the slides, the Q&A afterward. So let's go ahead and jump in. We have a lot to cover. Our main objective is to give you a solid technical introduction to Kubernetes using Rancher. What is it like adding Rancher to Kubernetes, going through workloads and all sorts of great stuff. We do have slides to get through, but this is mainly meant to be hands-on, interactive. We'll be doing a lot of demo and answering a bunch of your questions. We try to stay till every single question is answered. And for those who have joined these trainings in the past, we have a new feature. We really want to build the community around these trainings and get you guys interacting with each other, meeting each other, asking each other questions. So we created a Slack user channel that is public and free to join. So if you go to slack.rancher.io and go to the channel training-1129, that is the Slack channel for this training. Jump on there, talk, make fun of us. I hope I'm not opening a Pandora's box with that invitation, but please get to know one another. This is an open source community, and there's a ton of participation that is great to be a part of. So with that said, as a way of introduction, my name's Matthew Shear, kind of like the community advocate for Rancher. I'll be helping out on that Slack channel and answering some of the questions in the chat. You can reach me on Slack just through my name, Matthew. And you can also give a shout out to these trainings on Twitter if you are there with hashtag Rancher Training. Or if you have more follow-up questions, you can reach me through email at matthew@rancher.com. And my colleague and the person really who knows what he's doing on the line is Adrian, who's our engineer, and will be taking us through a lot of the meat of the presentation.
Hi, everyone.
Adrian. So just a little bit more context before we get started. We hope that you come in with some basic understanding of Docker containers. If you don't, I still think you'll get a lot out of this session. There are a ton of server setups that use Docker, use Kubernetes, and you will learn a ton anyway. But if you do have questions that are just very fundamental to how containers work, you can check out the Rancher blog, or Docker docs for more help there. And one more invitation from us is just to help us improve these trainings. There will be a survey at the end when you leave the GoToWebinar and in the follow-up email as well. And we use those to make these better. Couple other things. If you want to have your own instance of Rancher going while you go through this training, you can get one started really quickly by going to our website, rancher.com, clicking on the deploy button in the top right corner of the screen, and it'll bring you to this quick start guide. You can get started with Rancher in just a couple minutes, free and open source. And there's a ton of resources. This is a huge community, so go to slack.rancher.io. As I said, there's a ton of people talking about Rancher every day. Thousands belong to the Slack and to our forums, and hundreds are on there talking about different issues they're facing and solutions to those issues. And for this training specifically, you can join training-1129 and talk with each other there. So with all that out of the way, we're going to get into the meat of the material. I'm going to pass the presentation over to Adrian, who will hopefully be
Take
able
you
to
on a
get me
journey.
started. Yeah, I just shared it with you, and I can see your screen, so you're good to go.
Fantastic. Hey, everybody. I'm super stoked that y'all came to join us today. I see that we have a bunch of you here. As Matthew said, these trainings are done for you guys, and we want to make sure that the information that we're giving you is valuable um, and useful to you. So in the last few trainings, we've asked you guys to fill out this feedback form at the end. And based on the feedback that we've gotten from you guys, I've made some changes to how I'm doing stuff. I've increased the amount of demo, changed some stuff around, I've taken out some slides. So your feedback is valuable. And if any of you are here who have been here before, I'd be even more interested to know how you like today's training compared to others that you've seen in the past. So it only takes a minute to fill that out at the end, and it's super helpful for us. As far as the Slack channel that Matthew referenced, just so you don't think it's like some secret code, the 1129 is just today's date. So we're looking forward to seeing you guys in there, even though I'm not going to be in there right now because I'll be talking to you about Kubernetes. So let's get started. Where are my notes? There we go. All right, so Kubernetes. We all know that Kubernetes is here to stay. Uh, you know, I joke, like everybody says, do you remember where you were when such and such event happened? Well, do you remember where you were when you realized that Kubernetes had won the container wars? For a while, we were all basking in the glow of Kubernetes being the leader in container orchestration. But once the honeymoon faded, we were left with a myriad of choices about whose Kubernetes to use. So it's not just enough that Kubernetes is huge and powerful and everywhere and stuff. There's other stuff that we're going to have to consider. So you got Google's Kubernetes, you got Amazon's Kubernetes, you got Microsoft's Kubernetes, you've got Pivotal's Kubernetes, and every day it seems like there's another Kubernetes platform of the day. And those options mean more variables, and more variables means that there's a greater chance that whatever we choose could end up being the wrong choice. Like we've all been with providers that we didn't want to stay with, and moving off of a provider's infrastructure is painful. I mean, how many of us have stayed with a provider just because moving was less painful? We don't want you to be in that position. Kubernetes is open source software. Cool. In March of 2018, it became the second largest open source project after Linux. As of October 2018, it had 24,500 contributors across more than 100 companies. That's a massive ecosystem. Despite having massive participation from what seems like pretty much everyone on the planet, Kubernetes still has its challenges. You can add to this list of stuff the struggle between developers who want to release code or who want to run it on a platform where it runs the best, and internal IT departments who want to maintain control over security and access. So the result is that one side or another seems like they have to compromise. You've got Corp IT who might have to do more work to secure lots of platforms as developers go rogue and install stuff on their own systems. And if those guys miss something, the consequences are severe. On the flip side, you've got developers who just want to release stuff and get it out there and move on to the next thing. And they might be forced to use a platform that has fewer features, less functionality, is harder to work with. That results in dissatisfied developers. Nobody wants a dissatisfied developer. But what if there didn't have to be a struggle between those two things? What if there was a way to unite these two worlds like a digital Reese's peanut butter cup? In that world, developers could use any Kubernetes deployment anywhere, on-prem, in the cloud, with the providers of today, the providers of tomorrow. And in that world, Corp IT could push centralized role-based access control out to every cluster, no matter where it's running, with a click or a couple of commands. All of us could stop worrying about the things that we don't control, and we could all be confident that if we needed to move to a new provider tomorrow, we could. So pick your Kubernetes solution. Build it yourself the hard way, or do it the easy way with Rancher's Kubernetes engine. Put it in the cloud. Use a hosted provider. Doesn't matter. We can launch instances and install Kubernetes onto them. We can deploy and manage a hosted Kubernetes solution in any provider. If you already have Kubernetes clusters in the wild, we can import them and manage them like any other cluster. But what does management mean? It means that you can corral all of your clusters under one system, one highly available point of control, without sacrificing any of the individual cluster independence. It means that you can bundle namespaces into projects. You can map strong authorization roles that grant the correct level of access to those projects. It means that the Active Directory or the SAML infrastructure that you already have can control access to Kubernetes clusters that are running anywhere. It means that you can readily see and control your capacity, and thus you can control your costs. You can scale your infrastructure up or down based on metrics that you control. That all sounds great for cluster admins, but what about the people who are using the clusters? Maybe you're new to Kubernetes, or you just want to spin workloads up and down quickly. Great. Our user interface lets you deploy applications that are as simple or as complex as you need them to be, and it lets you do so quickly. What about monitoring and logging? Great, no problem. Use the integrated metrics server or the integrated logging server or plug in an external system of your choice. What about traditional access via kube control? Still there. All of it's available and all of it adheres to the RBAC policies. Do you want to package your application with Helm and make it available to others, or do you want the confidence that comes from using the Helm charts that others have made? Cool. Use the app catalog. What about CI/CD? Use Rancher's pipelines. This is the world of Rancher. This is what I'm going to show you today, and I am absolutely thrilled that you've decided to join us. So let's talk about Kubernetes. Kubernetes has some basic building blocks that you'll assemble into applications. If you've done some work with Docker, these are going to be a little bit different, but stick with us. It's not that hard. We'll start with pods. You're sitting there with a container image that you want to deploy. In Docker, you might just use Docker run to launch it, maybe exposing its port so that something outside the host can hit it. Have you ever gone through the hassle of linking containers together so that they can find each other by name? Have you ever ported an app that expects MySQL to be on localhost? If you've got two containers, linking them together isn't a big deal. But when you've got 3 or 5 containers and you start getting containers on different hosts, it rapidly becomes a hassle. All of this technology, everything that we're all doing is not supposed to make our lives harder. This is all supposed to make our lives easier. So as we're going through the rest of the training today, keep that in mind. We want to find the easiest path to getting things done better than we were doing them yesterday. Pods. Pods collect containers into a shared unit that combines network and storage. That's it. 99% of the time, you're going to have one container per pod. Maybe sometimes you won't, but don't worry about the time that you won't, because when you need more than one container per pod, you'll know that you need them. Best practices dictate that a container should run one process, period. And the structure of a pod makes it easy to adhere to that. I often hear that pods are confusing, especially for people who just entered Kubernetes because they're used to just containers. Don't sweat it. Like I said, you're going to run one container per pod most of the time. And if you want, if it's easier for you, when I say pod, just think container. It's not really that accurate of a map, but let's get past the part of thinking that we don't understand. Pods are simple. Now, even though you can run multiple containers in a pod, you definitely don't want to be running a web app and a database in the same pod because that doesn't scale. But you might run one app in one container and a log shipper in another. You might have a sidecar container that ships data out to an external service for processing and then brings it back to the main container, can do something with it. And as you start building your applications using 12-factor apps or microservices principles, most of the challenges of having each container do one thing are overcome by having them within a pod. So when you think about pods and how to assemble them, think about them as a scalable unit. If your application needs more oomph, you're going to start by going from 1 pod to 2 pods to 3 pods to 5 or 10 or however many you need to deliver the application. What's inside the pod matters because you're going to be cloning the pod. So in this slide, you got a file puller and a web server. So you can imagine that the file puller gets data from somewhere, from a CMS, from something outside, and it puts it on the volume. The web server shares the same volume so that it's now able to make that content available to its consumers. This is a perfect example of having 2 containers in a pod that share backing storage and that both are doing one thing, but that still depend on each other. In this model, you could scale this because each of those pods needs that function to retrieve the data and make it available for the consumers to pull from the web server. When you launch stuff in Kubernetes, you create what's called a manifest, and manifests are written in YAML. YAML, in true nerd humor, stands for yet another markup language. So this is a basic manifest for a single pod. It has all 4 required keys that you need for a manifest, which are API version, kind, metadata, and spec. When we launch this, it's pretty simple. You can see in the command down at the bottom, it's just going to say, hello, Kubernetes, and then it's going to sleep for 10 seconds, and then it's going to exit. Ask yourself, what's going to happen when it exits? And let's find out. So we will now see if we can change our screen. Oh, wow, just went to the next slide, which I don't want. There we go. we have this, and now I've lost my cursor. Multi-screen. Matthew, can you still see my screen? Can you actually see now that it's
Yeah. Yeah, I see
okay,
your old
cool.
screen. And yeah, I see your cursor now too.
Really? I know. Ah, there it is. Great. Okay. I love doing demos because demos never go correctly. I mean, just the simple act of switching from one screen to another and the universe ends. All right, so here we are. I've got this same, let me actually blow this up a little bit here so you guys can see it. So I've got this same pod here, and I've created a namespace in Kubernetes specifically for the training. So we are actually connected to my personal Kubernetes cluster because I'm one of those guys who feels the need to run Kubernetes in his house. And I've connected to the training namespace. So we're going to deploy this. Second here. So we're going to deploy this using kubectl apply. And that will take that manifest and apply it to the Kubernetes cluster. So if I get pods, you can now see that that pod is up and running. If we go and look at the logs for that, you'll see that it said, hello Kubernetes, which is exactly what we told it to do. After which, what does it do? It's going to sleep for 10 seconds, and then it's going to exit. So Kubernetes keeps track of the pod, and when it exits, it restarts it. You can see now we have 0 out of 1 ready. The last status was completed. You got restart 1. Let's actually follow this and see what happens over the course of, I don't know, the next 15 or 20 seconds. So you see now we've got restarts 2. Kubernetes doesn't understand that this particular pod is exiting and that that's what we wanted it to do. And in actuality, you don't ever want your pods to do this. Pods should be running all the time. They should be running services in the foreground where the only time that they exit is if something bad happened, because when it exits, you get crash loop back off, which is Kubernetes recognizing that whatever's running inside the pod isn't staying running. And so it's going to stop trying to restart it quickly. It'll slow it down. Now it's running again. This simply demonstrates that when the pod exits, Kubernetes restarts it. Cool. But let's delete this now. You see that I typed so many kubectl commands that I've abbreviated kubectl to be KC. Once you go down the Kubernetes path, at some point you'll be doing the same thing because there are so many things that we type, like kubectl-n, whatever. So you'll be making abbreviations. So don't be alarmed when you see KC. That's just kubectl, and then ns is a shortcut that I've written to change my Kubernetes namespace or tell me where it is. So let's go back to here. And all right, so you're basically never going to launch a pod yourself because there's just no point. If you have a pod running, you can't really do anything with it. You can't make more of them. You don't. So a group of pods is known as a replica set. And things that control replica sets, but we used to use a thing called a replication controller. It still exists in Kubernetes. It's still important that I talk about it. You're never going to use it. You're just never going to use it. But it demonstrates you have a replication controller, and, well, you see, a controller controls something. It's pretty obvious, right? We're actually going to use deployments to create replica sets, and I'll show you that in a second. But let's just talk about controllers. Replication controllers manage replica sets, easy enough. If you take any other controller object that exists in Kubernetes, for example, an ingress controller, what do you think an ingress controller manages? Ingresses. So generally in Kubernetes, you don't deploy the object, you deploy a thing that manages the object, and then you tell that thing what you want the desired state to be. So for example, in a minute, we're going to launch, well, heck, let's just launch a replica set directly. Lost my cursor again. It's so weird. It's like it stays on the PowerPoint slide even though it's on the screen. Okay, let's look at what a replica set looks like. Here's a manifest for replica set. You got API version, kind, metadata, and spec. Those are your 4 required keys. So metadata, this replica set's going to be called front end, and it's going to set some labels. Kubernetes uses labels to identify all of its objects, and they're also used later, as you'll see, for selectors to help one object find another object that it's supposed to care about. Under spec, you define what this object is that you're creating. In our case, we're creating a replica set, so everything else down from here tells Kubernetes what we want our replica set to do and be and so on. In this case, we want 3 replicas. It will find its pods based on this selector. The template defines how the pods exist. Sorry, shut off my phone here. The template defines how the pods exist, and there we go. And so you see, for example, in the pod, we're going to have one container. That container is going to have a name of nginx, and it's going to be running this image, 1.14-alpine. Ignore this commented out thing for now. And we've set some limitations on what the pod can use on the host itself. And we've also defined what port we want to expose on the pod. This will be used later when we do some other stuff. So don't worry about it right now. So if I run this, run is actually the wrong term. If I apply it, then, oh, interesting. Administration. My bad. Global search and replace earlier. Okay, so let's try this again. So you can see now, when I get the replica set, we have one replica set called front end, and we have told Kubernetes we want 3 replicas. Kubernetes says, okay, I've made 3 replicas, and 2 of them are ready. If you look at it now, it's going to actually say that we wanted 3, it gave us 3, and 3 of them are ready. That's great. We look at the pods now, we can see that it created 3 replicas, and it creates them with a slightly different name. It actually creates them with a name that corresponds to whatever its controller's name is, and then an identifier for each of the pods. So let's look at one of these guys. So if we look at the pod, kubectl describe will give you information about a resource and its state, where it is, the runtime state of the resource, versus kubectl get will show you an abbreviated status of the resource, or you can have it output YAML to show you the actual manifest that's controlling the resource. So in this case, we want to see some things about the pod. So we got container ID, what image is it running, some stuff about ports, not running on a host port, resource limitations, but I'm looking for where is it running. So this one is running on my host Rancher 03. Let's look at the other 2. Say kubectl. This guy is running on Rancher 01. And this guy is running on Rancher 02. So you can see that the replica set recognized that we have 3 nodes in our cluster, and it spread the pods across those 3 nodes. Because the replica set controls the pods, what do you think is going to happen when we delete it? It deletes the pods. So by creating a controller inside of Kubernetes, we have a thing that manages the stuff that we actually care about. But like I said, you're basically Oh, look, I have more images. You're basically never going to use a replica set. But where they're useful is when, sorry, you're never going to use a replication controller. You're never going to directly deploy a replica set. You're going to use deployments almost all of the time. There's some other stuff you might use, like daemon sets or stateful sets, but they're special. We won't talk about them in the training today. The reason that you want a controller that controls something is because take this image where we've got 3 nodes and we've got 4 pods. Basically, we have 12 replicas and they're spread out across all 3 of our nodes. When a node dies, the replication controller or the deployment that watches the replicas sees that it only has 8 pods running and it needs to have 12. So it will deploy another 4 and it will deploy them on whatever resources remain. It does this by monitoring the health of the pods, either are they running or are they not running, which is pretty easy for it to figure out. But you can also put health checks into your pod definitions, and you can then have Kubernetes understand, oh, it's a web application. And so if it doesn't return a 200 or 300 series status code to a get, then do something. Or you can have Kubernetes actually run commands inside of your container to determine the health of your application if it's not an application that exposes a network endpoint that you can easily talk to. So let's talk about deployments. These are where you're going to do most of your work. They're a level of abstraction above a replica set. And they give you a nice set of commands within kubectl that you can use to control the replicas, do updates to the images, and various other things running through your deployment. So here's our replica set again. We've defined a deployment that says that we want 4 replicas of our pod, and each of them are running with a specific tag like version 1.0. So this is actually a good time to point out that you never want to use the tag latest in your images. And that's because it's, well, so latest, if you don't specify a tag, latest is the default tag, and it will bite you when you try to do an upgrade. So imagine that you deploy a pod and it's running whatever, nginx latest. And that actually is really nginx version, whatever. I don't know what their version numbers are right now, but it's nginx version whatever. And they release a new version that you're not ready to migrate to. But suddenly your pod dies. And when your pod restarts, because it was using a tag of latest, Kubernetes will also set the pod to always pull a new image. So every time that pod restarts, it's going to reach out to the internet, to Docker Hub, or to whatever your container registry is, and it's going to pull down the latest version of the latest tag. And that might be a different version than you're running on your other pods. It might be an incompatible version where, if any of you are in the training who have ever done an upgrade or were around when we went from Apache 1 to Apache 2 or from 2.0 to 2.2 to 2.4, and you remember the nightmare of trying to port your configuration over, you don't want that to happen to you in the middle of the night. You want to use these systems so that they keep your applications running healthily. You certainly don't want the system, because it doesn't know, to do a restart of a pod, which is exactly what you told it to do, and have that result in the failure of your application. So instead, what you want to do is look on Docker Hub or wherever you're pulling your stuff from, look at the container image tags, and always pull the specific version tag for whatever it is you want to run. If it doesn't have a tag, you can also pull a specific image, although that results in really ugly looking container images. If you are a person who makes container images, do the same thing. You always want to tag stuff with a version number or release number when you push it, so that the people who consume your images are able to follow best practices. So that was a bit of a digression. Let's get back on track. We've got these 4 replicas, and they're running whatever this is, version 1.0. And there's a new version out called 1.1. We intentionally want to roll that out, so we update the deployment manifest and we tell Kubernetes directly to deploy new pods with that image. It does what we ask. It can either start new pods while the old ones are running, or it can kill the old pods and start new ones afterward. Whichever one you want, you can configure it to do. And it depends on what kind of resources the pods are using. For example, if your pod is using iSCSI storage on the back end, and so, for example, one of the mission critical applications that I run inside my home Kubernetes cluster is Plex, and it's very important. I have the Plex configuration shared via iSCSI, and it can only be mounted by one container, so one pod. So that one pod, if I want to do an upgrade of Plex, can't be running at the same time that the new pod is. So in that situation, when I do an upgrade of the Plex server, it will kill off the old pod before it starts the new one, and that way the backing storage is available for the new pod. If you don't do it that way, the new pod will hang forever. The old pod will continue running because it has no idea that it's not supposed to be, and you're going to have to go in there and pick something and shoot it. As the rollout rolls out, it starts killing off older pods. So it did an upgrade and then it removed 2 of the old ones. The rollout continues until now we have 4 new ones. And then that's our new deployment. So Kubernetes understands that we moved from one state to another one. And if for some reason version 1.1 doesn't work, we can roll back to the previous version. Kubernetes allows you to do rollback to just the previous, but if you're using Rancher, we actually allow you to roll back to any previous version in the history back to the beginning of when you launch your deployment. It's very slick. So now we've got a deployment. Well, let's see how this works. All right, here's my deployment manifest. We're going to apply it. Actually, you know what? Let's do this a little bit differently. There's a lot of different ways that you can spin something up inside of Kubernetes. One is you can create these manifests yourself, and then you can apply the manifest. Or you can use a command like this, kubectl create. So in this case, I'm going to create a deployment called Nginx, and I'm going to tell it what image I want it to run. And I need to, there. So tell it create a deployment, name's Nginx, run the Nginx 1.14-alpine. And you can see now that we have exactly what we told it we wanted. So there we go. We have an Nginx pod running. That's pretty easy. This is cool if you know what you want to run. I don't know if this is actually a real image, but this is way faster than building manifests in YAML. It's not as fast as launching stuff in Rancher, but it's, if you just know you want to spin up an image and then you'll talk to it later or whatever, it's super fast to do kubectl create. Let's just do kc apply -l deployment. So we'll do it this way just so that I know that my names are all correct and stuff as I continue doing my demo. This results in the same thing. See, we still got our Nginx, and there's a pod that's running there, and that's cool. So let's go look at the pod. Here you can see that it is running Nginx 1.14-alpine, and when you describe the pod, this is also where you'll get log information. If something's not launching, if it's in crash loop backoff, or if it's stuck in a pending state, the events related to the launching of whatever the resource is, if you describe it, it'll show you information and it'll tell you why it's unable to do stuff. Can't find backing storage, permission denied on something, whatever the problem is going to be inside of here. Okay, so we have one replica running because that's all we told it that we wanted. But let's say that we want more. We want 3. kubectl scale. Tell it what you want to scale and tell it how many replicas you want. When you're doing, it's faster than we could actually look at it. When you're doing a change to a deployment, you have the kubectl rollout command, and this will tell you the status of your deployment. You'll see me use this several times throughout the demo. This will tell you the state of things as it rolls out new replicas and kills off the old replicas. In this case, it just spun up 3 new replicas because it was really fast because it's an Alpine container. The deployment now says that we wanted 3, got 3, 3 of them are up to date because we've now done a change, and 3 of them are available. That's cool. And if we look at the pods, you can see that we actually do have 3 pods running. Also very cool. Now, another reason that you want to use deployments is to change the image. So let's update it. So what I'm telling it here is kubectl set image. I'm telling it the deployment to use, which is the Nginx deployment. And now remember that a pod can have multiple containers inside. So the deployment spec could have multiple containers defined. We want to tell it which container we're updating. In our case, there's only one, and it happens to have the same name as the deployment because we didn't, so we're not fancy. So that's how we provisioned it. So we're saying set the image on the Nginx deployment, take the Nginx container, make sure that it's running the Nginx 115 Alpine image, and record what you did. Record is important for being able to roll stuff back. Except I'm going to actually break this by misspelling Alpine. Oh, it's been updated. Let's watch. What do we got? So it's waiting for the deployment Nginx rollout to finish. Pretty much any time that you do an update, you're immediately going to follow it with a kubectl rollout status so that you can see that your change is actually taking effect. Now, we know from a moment ago that this should have rolled out faster. So we don't know why. Let's look at the pods. Oh, interesting. Image pull back off. Well, let's go look at that pod. And down at the bottom, you see here, failed to pull image, Nginx 115. Oh, because we misspelled it. Okay, so how do we fix this? We roll it back. That easy. It's gone. It's gone. We're just right back to where we were a second ago. Now, nothing actually changed while we were doing the rollout because Kubernetes was smart enough to say, oh, I'm going to go get this image before I start killing off pods, and it realized it couldn't. So our entire application just continued to run happily. Our users are happy. Nobody knew that we made a typo. Now we can scroll back up and fix it. But we're actually not going to do it that way. Let's do it differently. Remember I told you that there's lots of ways you can do things. This would be one way. Another way is we could edit the deployment. So if I change the image here and apply it again, Kubernetes will figure out that there's a change and it will go and faster than I can type, it will go and make that change. So interesting. The deployment, we had 3 replicas running before. Oops. And in addition to changing the image, I also set it back to replicas 1. So let's show you a third way to change that. It's possible to directly edit the manifest running inside of a Kubernetes cluster using kubectl edit. Now, if you do this, well, here, let's just edit it first. Ooh. Don't be alarmed. There's a lot of other information in here that's just status information and other stuff not related to what you're actually going to care about. So in this case, we're just going to change replicas to 3. And still too fast. And there we go. We got 3 replicas again. Now, the caveat of doing it this way is that Kubernetes knows that I edited the deployment inside the cluster and that it's different from this deployment here. So depending on how you generate this deployment file, Let's use this to change our replicas back to. Okay, so in this case, it's okay because our deployment doesn't actually contain a whole lot of identifying information. But let's do see get deploy nginx -o YAML and write that out to a file. This is yet another way you can do things in Kubernetes. So now you can start changing stuff in here. So let's change replicas to, actually, let's leave this alone. Let's edit it. And let's change replicas to 3. And what I want to show you is that, so we just made a change directly in the cluster. We can come in, we could edit it here as well. Let's change replicas to 2. So, now we made a couple changes in a couple of different ways. And now if I try to apply new deploy, it should get angry. And it should tell me no. Yeah. Ooh, that's a big ugly error. The reason is because it knows that changes have been made to the deployment since we generated it via the extracting from kubectl get. So if you're going to make changes directly in the cluster, just understand that your kubectl apply might not work again. Oh. That's alarming. Might have just killed my cluster. That's how much I love you guys. Oh, yay, and it's back. Okay, we can continue our demo. That was going to be fun. The demo would have transitioned from learning Rancher and Kubernetes to troubleshooting your Rancher cluster when you kill it. So we'll get rid of that. Let's see the state of our deployment. We got 2 replicas. All right. So that was a whole lot of stuff around deployments to demonstrate that there are many ways to do things, all of which really come down to you tell Kubernetes what you want, and Kubernetes will do everything in its power to not only give it to you, but to keep it that way. And what does that mean? That means for some reason something happened and our pod got deleted or crashed or something. What's Kubernetes going to do? It's going to start another one. So Kubernetes will keep our system in the desired state that we told it that we want. Desired state, current state, always moving to the desired state. Always making sure that those two are equal. If current state is not equal to desired state, make a change. Now, once you deploy some pods, you want to do something with them. I told you in the beginning that pods share network space and storage. So the network space is important. All pods are given their own IP address, but as you've just seen, you can't rely on pods. They're totally unreliable. They could get deleted for any reason. They could crash. They could get moved around. There's all sorts of reasons why a pod is what we say is ephemeral. It could be here now and could not be here a moment from now. Therefore, even though they have a specific IP address, you cannot use them. You need a stable endpoint that tracks the comings and goings of pods and load balances traffic across them. Introducing services. So a service is just that. It's a stable IP address. It uses a selector to find pods that it cares about, and then it load balances traffic across them. As pods come and go, the service figures out that pods have come and gone, and it continues to send traffic to the pods that are there, and it stops sending traffic to the pods that aren't. Wouldn't be much good if it didn't do that. Now, there's 3 types of services. Cluster IP, node port, and load balancer. Cluster IP is the default, and cluster IP gives the service an address that is just visible inside of the cluster. This is useful if your service and the other pods are being consumed by other resources inside of the cluster, or as you'll see, it's useful when you start adding additional types of services. So cluster IP, just understand, only visible inside the cluster. Node port is the next step above that, and node port opens a port on every single node in the cluster. Now this is a high port between 30,000 and 32767 by default. Although you can change that in your cluster launch if it matters. This port is usually random, and pretty much the only reason you're going to use a node port is if you have an external load balancer. Now, the way that a node port service works is it also creates a cluster IP service. The node port service sends traffic to the cluster IP service. The cluster IP service sends traffic to the pods. You go one step above that, and if you are deployed inside of a cloud provider, Amazon, Google, etc., then you can create a service of type load balancer. And as long as Kubernetes has been told what cloud provider it's part of, and as long as it has the corresponding credentials to make changes, then when you deploy a service of type load balancer, Kubernetes will actually create an external load balancer in the provider. It'll create an ELB, for example, or whatever Google's load balancer is called. It then creates a node port service. It configures the external load balancer to send traffic to the node port service. It also deploys a cluster IP service. So it goes load balancer, node port, cluster IP, pod. It looks something like this. So the IP address might be public or private, depending on what kind of service you deployed, and it does what it does. What does that look like for our demo? It looks like I once again get to show you that there are various ways to do things. If you want to use kubectl, 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 whatever you feel like calling it, if you want to use kubectl, and you already have a deployment, you can expose that deployment. And I told you cluster IP is the default. In our case, we want to use type equals node port just because that's what I want to demonstrate to you. And Kubernetes will figure out what is inside of the Nginx deployment, what ports do they have, where are the pods, what is their selector, and it will create a service for us. You see here, 31957, that's the port that it just opened up on all three of the Rancher nodes. So that means that I can do something like this, -I, Control-1, 31957. There we go, that's our Nginx. I can do the same thing on Rancher Row 3. I can do the same thing on Rancher Row 2. Kubernetes will, it's the welcome to Nginx page. And actually over here, I can just go directly to that. Good one. Back up. There you go. There's our Nginx page. Let's delete that and show it differently. Actually, before I delete it, do you remember I told you? Remember I told you I can't type. Do you remember I told you that in the deployment we have a container port? This exists solely for automatically creating services. If you don't have this, Kubernetes doesn't know what port your container is listening on. It doesn't know where to send the traffic. Now, you can get around that by creating services that expressly tell it where to go. But if you want to use kubectl expose and just do it really fast, make sure that you include what ports your container is listening on. You can look at the documentation. Obviously, you can have more than one port. If you have more than one port, then you name your ports and stuff. Just the Kubernetes docs will explain that. So let's look at my notes and figure out where we are. Comment the port. Okay, so let's edit the deployment. Let's comment that out. Let's apply it. Now, that doesn't actually change anything on the pods themselves. It just changes the Kubernetes configuration for the pods. So if I delete the service, and then we go to redeploy it with kubectl expose, you see that Kubernetes is mad because it doesn't know what port to use. Okay. What if we want to tell it? We can tell it. We can't use kubectl expose if we're going to tell it. We have to use yet another way that Kubernetes allows us to do things. So actually, I got ahead of myself. We can tell it what to connect to by okay. So in this case, if we don't have the port specification in our container, in our pod manifest inside of the deployment, then we can tell it with type node port what port to connect to, or with type cluster IP what port to connect to on the container. So the next thing is you see that this picks random ports. So earlier it was on 31957, now it's on 30023. We'll try to go to this. If you don't tell it where to go, or sorry, if you don't tell it what port to use, it will always assign a random port. That's not so good if you're using external services like load balancers and you want to make sure that your service gets redeployed for whatever reason, it's on a stable port. So what if we want to tell it where to go? For that, we need kubectl create. So I'm telling kubectl now, create a service of type node port, give it the name of nginx, use the port 31337 on the hosts, and send it to a cluster IP service on port 80, and then to a container or a pod on port 80 as well. So when I do that, you'll see that it created a node port service and it used the port that I asked it to. So over here, we can go and there we go. So this is so cool, but we don't want to manage ports. I mean, unfortunately, my house isn't an Amazon region, so I can't demonstrate to you using load balancer. Although if you do deploy Kubernetes inside of someplace that's not a cloud provider or that's an unsupported cloud provider, if you have access to multiple IPs, you can check out Metal LB. Metal LB is a great way to deploy a software-based service load balancer. It's pretty slick. It's a cool project, but that's not what today's demo is about, so I'll let you guys check that out on your own. Let's redeploy this as a cluster IP and put an ingress in front of it. We have a service of type cluster IP, which means it runs only inside of the cluster itself. That's its IP address, and it's going to port 80 on its pods. Cool. Let's talk about ingresses. An ingress takes a service and exposes it outside of the cluster. That's it. So the Kubernetes component that does this is called an ingress controller, and it's responsible for configuring a load balancer to route traffic, usually by hostname, optionally by path. So if we go back to the microservices concept from earlier, you can imagine now that we could have different pieces of your application running under different pods, and the ingress routing, for example, slash checkout could go to one place, slash store could go to a different one, slash search could go to a third pod. Sorry, not pod, but deployment, replica set, group of pods, a set of pods that represents those pieces of your application. Now you can have those pieces built independently, maintained independently, scaled independently, and now you're in microservices. Ingresses can point directly to a workload, but we usually point them to the service, the stable endpoint that we created earlier. So imagine now you've got somebody outside your cluster and they've got a browser. That browser hits the ingress. The ingress routes to a service. The service routes to some pods. I told you in the beginning of this demo that Kubernetes isn't that complicated. Once you understand the components, then everything that you're doing is just wiring those components together. So let's go create an ingress. You can do ingresses in a few different ways. The first ingress that I'm going to show you is a simple ingress. And we're going to have a host name. And we're going to say send slash to the service called Nginx on the port 80. Since that's what we created up here, if you have a service called Nginx that's listening on port 80, then that should work. This tells us that it created what we wanted. These are the hosts, the host name that it's connected to. And eventually something will show up under address. It takes the ingress controller a little while to determine that everything is healthy before it actually puts stuff in there. But it'll still work even before it tells you what the addresses are. In our case, I've already created a host name for training.cl.monaco.us. And so now if we come over here, there's our Nginx page. Okay, that's cool. This will load balance traffic. How many pods do we have? Scale it up to 3. So this will load balance traffic across all of them, but you can't see that. In a minute, we'll deploy something else that actually shows you that the load balancing is working. To do that, we'll use a different kind of ingress, which is referred to as a simple fan out. So here's the manifest for a fan out. A fan out sends traffic from a single endpoint to multiple backends. In our case, it's the same as what we had before. We're going to send slash to our Nginx service, but we're going to send slash rancher to a different service. Looks the same, fan out ingress. You see this guy was a little quicker to figure out his names. And now if we come over here and we refresh this, it's actually going to look exactly the same because what are we doing? We're sending the traffic from slash to, well, slash. Same thing we were doing before. But now, what if we want to go to slash rancher? 503. Why do we go to 503? Because we haven't yet built this service, but we can do that really fast. We're going to create a new deployment called Hello World. And we're going to use the Rancher Hello World image. See it's in container creating. Let's just let that. Oh, and now it's running. So -W will hang out and refresh whenever there's a change. So you see that when Hello World changed from container creating to running, it gave an update. And so now we know that we can exit that. And now we have to expose it. Do you remember how we do that? And that failed because when we launched it with just a simple uh, with a simple deployment by creating the deployment here, and that didn't specify a port. So we want to now say what our port is, and now the service has been exposed. Sorry, now the deployment has been exposed by a service, and you can see it's a service of type cluster IP, and its name is hello world, and that means that when we come over here and refresh, well, we get an app, but it doesn't look good. It's okay, it's not supposed to look good. That's part of the demo. The reason it doesn't look good, the reason it doesn't look good is because of the way that we're doing the routing. The container, let's see, how can we show this to you? Make sure there's cat thief fan out here. So when we send traffic, so the ingress receives traffic on /rancher, and it sends it to the hello world service and so on and so forth. The hello world service doesn't know anything about the path /rancher because it's just configured to listen on /. So in order to make sure that when we make the backend request, we've told the ingress, if you receive something on /rancher and you go to this hello world container, make your request to /. And that's cool. Okay, that's why the page loads at all. But what happens, if you do an inspect here, and look at the console, you see that we have a whole bunch of 404s because it's trying to load images from /. Well, in this case, /image. But from the outside where we're sitting, that path actually needs to be /rancher /image. Well, the fine folks who built the Nginx ingress controller recognize that this is probably going to happen in the real world. And so you have an annotation, in this case, add base URL. Every single ingress controller, in fact, pretty much every Kubernetes object has annotations that control how that object behaves. In the case of the Nginx ingress controller, the annotations are translated into Nginx configuration directives. So now, when we apply that, and we come over here, and we refresh, suddenly our images load. So this container that's serving our traffic right now is 5C2WX, and as I refresh, it should have actually been load balancing. I'm not sure why it's not. That looks like caching. Well, it is supposed to be load balancing, and the demo is supposed to show you that it's load balancing, but whatever. We can at least just show you that it works. And for a demo, I'll take it. So that is how ingresses work. Now, there's some other cool stuff about ingresses where by default, an ingress expects that the communication is HTTP or HTTPS. It's some kind of HTTP workload. But if you're using an ingress to expose services to the outside world, not every service is an HTTP service. You might have a database or MQTT or something that already has TLS encryption built into it, and you just need to expose the port. For that, the ingress controller lets you use what's called a config map. Config map lets you store arbitrary things. So using a config map with an ingress is just one example, and I can actually show you here. Where do I have a config map? Actually, NS. Here, for example, is the config map for TCP services for the Nginx ingress controller that under data, you see that it's mapping ports. So these are TCP ports for the ingress controller is listening, and they're mapped through to namespace/service and then a corresponding port. This allows me to map a whole bunch of things that don't speak HTTP or that speak it on different ports via the ingress into the Kubernetes cluster. Now, that's just one thing that you can use config maps for. You can also use them to create uh, entire configuration files, to do environment variables, to do basically anything where you need to configure a container that's running inside of a pod. So the purpose of a config map is to answer the question of how do I get unique configuration into the container? Maybe you used to do it with volumes, or you used to roll your own containers with your config baked in, or anything. With Kubernetes, you don't have to do any of that. You just use a config map. So here, for example, are 3 different pods running the exact same image, but each of them has a different config map. The one on the left is using dev. The one in the middle is using QA. The one on the right is using prod. So you can change how your pods exist by changing the config map that you've attached to. I actually have a whole bunch of other stuff to show you about config maps, but I told you I rebuilt this slide deck today, and apparently it's too long. So I'm going to have to skip that and make sure that we get into the Rancher stuff. But before we do that, before I take some questions, if you want to learn more about microservices and building distributed systems within Kubernetes, check out this book. It's written by Brendan Burns, who was and possibly still is Director of Engineering at Microsoft, at Azure. So I'll caveat it by saying that the reviews on Amazon are kind of hit or miss, and I haven't personally read it, but the general consensus is that it's a good primer for helping understand concepts and give you information to decide where to go next. And of course, as you're no doubt aware, there's literally a bajillion web pages out on the internet with information. I recommend that you check out the docs on kubernetes.io. They're excellent. And when you get into the Rancher stuff that we'll be doing in a moment, check out our own documentation because it's also very good. We work really hard to keep it up to date. So before I dive into showing you a deployment with Rancher, I'll pause and take some questions. What do we got, Matthew?
Awesome. Thanks, Adrian. Super cool stuff. So the first one is from Jeff K, who says, in this scenario of multiple ports, multiple pods per server, would you use node port, host port, or others for your networking to avoid conflicts, i.e. port 80? You might have already covered it in your demo because you asked it a little while ago, but I think it's still worth asking.
Yeah, so I don't ever use node port, host port. In fact, I didn't even talk about host port. All my services are cluster IP, and I put them behind an ingress. And that way, if something's listening on port 80, then it's some sort of a HTTP workload. And so you can do what is effectively name-based virtual hosting inside of the ingress, where it'll respond and route based on host header. So it's not just path. You can send all your traffic to port 80 or 443, and the ingress will route it to the appropriate service inside.
Awesome. And Jeff actually has 2 follow-up questions. And just for everybody, they're both on the training Slack, but just put the questions for Adrian just in the regular questions chat on GoToWebinar, and you guys can talk to each other on the Slack. So anyway, so Jeff asks, you mentioned there's 3 types of IPs for pods. However, there are definitely 4 shown: host port, node port, cluster IP, and load balancer. Could you define the difference between these 2?
Yeah, so I didn't talk about host port because I don't use it. Host port will open a service. I'll explain it and you'll understand why I don't use it. So a host port will open a port on the host where the pod, so a host port will open a port on the host where the pod is running. And for me, that puts me in the position of managing where I put the pod. Like you guys have seen in my home cluster here, I have 3 Rancher nodes, and I don't want to say this pod goes on this node. I want Kubernetes to do that for me. And if that node goes down, the pod should go somewhere else. So I always just put pods wherever they are. And granted, you might have a host that has a bunch of RAM or some SSD disks, and you want to put some stuff on there for specific reasons. But even then, you would group those hosts into a group, and then you would select that group with the pod, and it will prefer that group. but you don't want to be in the business of managing where these resources go. You want to be in the business of creating a dynamic structure where Kubernetes puts them places, and then through labels and selectors, all of the other things find where they are. So as nodes go down, the whole thing heals on its own, and you get to stay at the beach or stay in bed at night or do all of these other things that you should be doing with your life besides managing ports.
Awesome. Thank you. The next one is from Anthony, who asks, do the cluster IP or does the cluster IP address have to be real, and real is in quotes, IP addresses on the network?
No, cluster IP exists only within the cluster itself. So, yeah, sure. So this address here, let me put that up at the top so it's a little easier to see. This address here, this 10.43, when you build the cluster has a /16 of space, which is 65,534 usable addresses for services. It's got another /16 of space for actual pods and stuff themselves. So no, they don't have to be real addresses because cluster IP exists within the cluster itself.
Awesome. The
I could
next
talk
couple,
more about that, but we don't have time for me to get into
yeah,
the nuances of like different types of networking and stuff.
cool. So the next couple questions are on the Rancher UI. So why don't we can wait on those and you can get more into the
Yeah,
demo and then we can come back.
yeah. Okay, cool, sweet. Let's do some ranchering, which is my home cluster, and that's not where we're going to do anything. All right, so I've got two nodes running over here. The top one is going to represent a server. The bottom one is going to represent a node. And if you've never deployed Rancher, it's like, well, you'll see. It's super simple. Get the notes back here, so make sure I don't skip anything. All right. I'll explain this in a second, so don't freak out. Rancher 2.1.2 came out yesterday, so that's the version that we'd like for you to use if you are running in production. Well, actually, that's not true. Let me explain our naming conventions here. So we've got latest. I told you earlier, you don't want to run latest for stuff that you're running in a production environment, but latest actually represents the latest version, the latest released version of Rancher. In this case, that's going to be 2.1.2. When something has been out for a little while and we know that any unforeseen issues have been worked out, we then tag it stable. Stable is what you should be running in production. Stable is stable. If you go to our releases page, we identify which is latest and which is stable. And in all cases, I recommend that you run a version tag. So for today, I'm going to run 2.1.2, even though it just came out yesterday. Previous stable was 2.1.1, but whatever. So I'm going to start the server. And what I've done here is I've said run daemon restart is unless stopped. I've mapped port 80 and port 443 through to the server. I've added a volume for varlib rancher mapped to opt rancher on the host because we're launching rancher in a standalone single container mode. This is not HA. This is not reliable. If this goes down and you don't have some kind of persistent storage mapped to it, you will lose your configuration. So if you're just messing around with it, you don't actually need this, but even if I'm messing around, I don't like losing things. So I always map a volume through. And Rancher's going to go and do his thing. By now, he's probably... So he doesn't take very long to start. Yeah, he's already running. First thing you're going to have to do is set a password. I'm going to set a horribly insecure password for the sake of the demo. And the next thing he's going to ask you is, where does the server live? This is very important to get right because your nodes are going to need to talk to this. The Rancher agent running on each of the nodes is going to talk to this host name to communicate with the Rancher server. So if you have a server running in your office, for example, and you want to deploy stuff out on the internet, make sure that you use something that's internet facing, a host name, IP address, something that they can talk to. If you get it wrong, things just won't work. It is possible to change it later, but certainly try to get it right the first time. So this is our UI. I'll talk through the UI while the cluster is building, but since we're going to be short on time here, I will just deploy a cluster, and then I'll talk through while it's good stuff. So we're going to deploy a custom cluster that you can see here that we deploy stuff into anything: GKE, EKS, Azure's Kubernetes service, AKS, whoever is the Kubernetes du jour of tomorrow. We can also stand up nodes directly in cloud providers, and we do full lifecycle management. So we can spin up the nodes in EC2, deploy Kubernetes onto them, scale them up and scale them down. And if you're done with the cluster or the nodes or whatever, we'll actually terminate the nodes as well. So full lifecycle management of any cloud resource. If you have a Kubernetes cluster running already out in the wild, we can import it, and you get 100% of the functionality of the Rancher UI. The only thing that we can't do is control the hosts on that cluster or scale things up and down because we don't know how it was deployed. But this is great for bringing clusters in the wild under the authorization and authentication and management of a Rancher server. Today, we're just going to do custom. Custom will give us a Docker command to run. And in this case, since we're only going to do one node, I'm going to have that node take all three roles, which are etcd, control plane, and worker. We'll talk about node separation here in a second. Copy this to the clipboard, come paste it over here, and that's going to go launch. And you see, boom, one new node has registered. This will take not that long because I also run a caching Docker registry in my house. So it'll pull everything pretty quickly and fire it up. But while it's doing that, let me just talk through some of the high-level stuff on the UI, and then we'll just deploy a quick workload so you can see how easy it is to deploy stuff in Rancher. One Rancher server can manage hundreds of Kubernetes clusters, each with their own role-based access control. You can take your central authentication and authorization system, Active Directory, LDAP, Ping, SAML, whatever, GitHub, and you can create policies, and then you can apply those policies universally across all of the clusters that Rancher manages. It's fantastic for maintaining control over stuff. Your clusters would show up here. If you use any external node provider other than the ones that we have enabled by default, you can enable them here. If you don't see the one you want, you can write your own. It's not that complicated, and you can add them here. I'll talk about the app catalog in a second. There's the Rancher catalog that we enable by default. The catalog are Helm charts. If you wanted to enable either of the other two main Helm repos, stable or incubator, you can do that here, or you can add external third-party application catalogs, and those apps will be available inside the cluster. That'll make sense in a second. As far as security goes, here's where you would enable whatever provider you're using. And once you have that enabled, you would see the users appear over here. You can then set up roles that control who's allowed to do what at the global level, at the cluster level, or at the project level. And then you map users to roles, and then you map roles to clusters. Well, you map users to roles, and then when you assign users to clusters, those roles carry with them. It's a better way to say it. Within our cluster's not done provisioning yet. Okay, so I'll talk about storage then. So at the global level, you can define walking my UI. Actually, yeah, so storage is at a cluster level, and since I can't click that while he's updating his screen, we'll jump back out to global. Users. I told you that you can change that server URL if for some reason you get it wrong, or if you start out with a single Rancher server and you're pointing to a direct IP and then later you add a load balancer to it or something like that, you want to change that, you can change it here. And the agents on the nodes will automatically update as long as they can reach the old one. So if you're going to do a migration like that, you want to keep the old listening point open, change the config to the new one. The next time that the agents pull an update, they will reconfigure themselves to talk to the new one. And so after a few minutes or whatever, you can then kill off the old one. Our cluster is now up and running. And so you have a couple ways to get into it. You can either select the cluster here at the top level. We see we have two projects already enabled by default. or you could just click the cluster's name itself. It's the same thing. You get some high-level stats of the state of the cluster. You saw my cluster freaked out with etcd for a moment and then recovered. So you can see these things here, and if you click on any of these items, actually I guess under nodes, you can get more information on the individual nodes themselves and what they're doing and so on and so forth. Back at the cluster level, you've got two options here for using kube control. One is you can just click launch kube control, and actually from anywhere you can just hit backtick and it'll open a kube control shell. And this is great for running all of the kube control commands that you saw me doing directly on the cluster without you having to have kube control installed locally. If you do want to install kube control locally, we give you a kube config file here. You can just copy this to your clipboard, put it on your local machine, and run kube control commands directly from your local machine. All of this authentication is proxied through the Rancher server, so all of the RBAC stuff carries with it. A user will only be able to see and interact with the cluster to which he has access. You can directly configure persistent volumes here, or you can define storage classes. Storage classes are cluster configurations where the cluster knows how to provision a certain type of storage, like Amazon Block Storage or NFS storage or something like that. And then workloads simply say, hey, I want some storage of this type, and they're given storage. They don't need to know where it is, what it is, or how to talk to it. We bundle stuff in projects. So Kubernetes has namespaces, which are logical groupings of objects so that you can use the same name in different places. But imagine you have a group of developers and they work on 3 different applications, and each of those applications are deployed in their own namespace. You could create a project that encompasses those 3 namespaces, and then you can assign people to those projects. So it's a way to get collective RBAC for namespaces and to give people permission to control larger groups of things without you having to do a whole lot of extra configuration. We do ship with some cool tools. We have alerts, which are backed by Prometheus and the Prometheus Alert Manager. So you've got alerts and then notifiers to the endpoints. For logging, we can, it's interesting. We used to have an experimental embedded Elasticsearch. It looks like they pulled that out for the moment. So for now, you can plug logging into any external provider that you have. You can see the ones that are available here. Go down one step further, and now we're in the default project. And you see here at the top, we've got some options: workloads, load balancing, service discovery volumes, and pipelines. Let's go ahead and deploy something. Your options for deploying stuff are scalable deployment of one pod. That would be a deployment and the number of replicas that it's going to have by default. You can run one pod on each node. That's known as a daemon set. You can run a stateful set. You can run jobs. So jobs are jobs. They're workloads that start, do something, and then exit. They're jobs. If you want to run them just when you need them run and you do it manually, or if you want to run it once, you create a job. But if you want them to run on a schedule, like backups, which is the thing that I unfortunately don't have time to show you guys today, you would set up cron here and it'll run the job at those intervals. In our case, we're going to run a scalable deployment of one pod, and we're going to run supersed Rancher demo. I know I'm going to run out of time here in 7 minutes, but I'm going to stay until you guys, I'm going to try and finish this in the next 7 minutes. But any of you who have questions, just know that we're not going to end it in 7 minutes. We're going to stay until the questions are answered, or until if there's anything else you want to see, or whatever. I don't have anything else to do today.
Me too.
So you can configure other stuff in here. For example, you can assign volumes. We didn't talk about secrets. Secrets are a way to securely store things like API keys, SSH keys, passwords, things like that inside of the Kubernetes cluster itself, and then securely mount them inside of a container or a pod, well, inside of the container in the pod, so that so that the workloads can actually use those resources. You can also mount config maps. You can do a whole bunch of really cool stuff with volumes besides just storage. There's additional configuration that you've got down here. If you click advanced, you can control the command, you can control host-based networking, how DNS works. You can do additional labels and annotations. and then a whole range of things around how the security of the pod and the host work together. Do you want it to be privileged, not privileged, etc. Kubernetes clusters also have what's called a pod security policy. So at the global level, you can define rules for what pods you will allow to run within a particular cluster. And so if somebody, for example, tries to start a pod that runs as root, it just won't start. So those are pod security policies, and they're a higher level above this. In our case, we just want to launch the workload just easily. Here's where you can have health checks. Let's actually give an HTTP health check slash, and because that'll be fun. And we'll say port 80, and we will say launch. Once again, they should pull pretty quickly and should launch. And when it's ready, we will see it. Just for kicks, I'll jump out here to the cluster and I'll say kc get pod. Oops. Just spell it out. All right, so the pod is running, but you see that it says ready 0 out of 1, and that's because the health check hasn't cleared yet. The health check's actually going to fail because I told it to listen on port 80, and the pod is actually listening on port 8080. So if we want to fix that, we're going to come in here and we're going to edit the deployment. We'll change the health check, and we're going to tell it to run on port 8080. So change that as well. We'll say upgrade. And now it should run. If it doesn't, I'm just going to remove the health check. Oh, crash it back off. All right, I'm just going to remove that health check because we're running out of time. Oh, wait, no, now it claims it's running. Oh, yeah, now we're good. Okay, so I don't know what that crash loop back off was. That must have been the other pod. But you see now we're good. We're up and running. Now we want to be able to talk to this. So because we didn't open a port on it. It's going to say because we opened a port, but we didn't. So let's publish the container port. We're going to publish it as cluster IP, and we're going to publish the same thing. Here's where you see the 4 types. So node port is a service type, cluster IP is a service type, load balancer is a service type. Host port is actually on the pod, if you want to expose the pod directly on the host where the pod is running. I told you I don't use that. So we're going to do cluster IP, we're going to say upgrade, and this will just take a second, and it will now create a service over here of type cluster IP, and it's mapped through to the Rancher demo deployment. Great. Last thing we need to do then is add an ingress to this. By default, you can create a hostname under xip.io. If you don't know about xip.io, it's great for testing stuff. It will create basically anything you look up on xip.io is done in the form of an IP address. So 172.20.20.20.xip.io will return the address of 172.20.20.20. You can look up any address in the IPv4 network space and it will return that address. So it's great for testing stuff internally or even using stuff internally where you maybe don't have DNS control. So we're going to say generate an xip.io hostname. By default, we'll also go to a workload. We're going to send it to a service. Our service is Rancher demo, and it's listening on 8080. That's cool. If we had SSL certificates for it, we could add them here, additional configuration, but we don't need that right now. We're just going to say launch. And it's going to take it a second to create the xip.io reference. So we'll have to wait for that. And when it's done, it'll actually put the link here. So it's going to take a second. Oh, I was going to ask for a question, but there's not enough time for that. Now it's here. So you see rancherdemo.default.ipaddress.xip.io. Sweet. If I select that, it's going to open this. This is our cool Rancher demo thing. You see we've got one cow running. That represents the one pod. Sorry, yeah, the one pod in the replica set. And requests are going against it, and this is actually the name of that pod. We jump back to here, come back to our workload, and say we want to run 3 of these, then it's going to scale. It's going to launch 2 more. It'll add them to the service. It'll add them to the ingress, and we should actually see them show up as additional cows. There we go, 2 cows. You see up here, we have all 3 of our replicas running. There's 3 cows, and now you can actually see the load balancing happening down below. That's a very quick introduction to deploying stuff with Rancher, and you can see that doing that is way easier than using Kubernetes manifests. I wish we had more time. There's other cool stuff that I can show you guys if any of you want to hang out. Just ask it in the questions, but I'll stop here since I've used too much and answer whatever other questions we have left.
Awesome, Adrian. Okay, super cool. So let's get to the questions. The first is from Mrunal, who says, the Rancher UI shows the compute details like CPU on disk, etc. But actually on the host server, it seems different. What is the source of truth?
That's interesting. Let's see. So, okay, actually, I think I know what he's referring to. What okay, so this isn't actually showing what's used. This is showing what's reserved. And when you're deploying stuff in Kubernetes, you actually saw this with my deployment. No, it wasn't there. It was in the thing that I didn't have time to show you, which is Big Math. Yeah, so here's an example where the pod has been told what CPU limits it has. So you can set reservations where you can guarantee a certain amount of processing power or memory for your workloads. And it's theoretically possible to oversubscribe your nodes or oversubscribe your cluster. You could have apps running where if everything used all of its memory, it could be more RAM than what you have in the cluster. So these stats are showing what you have reserved. And then as far as the usage, let's see if that's accurate. So down here, it looks like 7%. So basically, I've got 2 gigs of RAM, and it's using 920. Yeah, that doesn't actually look like it's an accurate representation of what's in use on the node. So I'm not sure. This may simply be showing. I'm trying to do math right now to figure out what 7%. 7% 2 gigs would be 140. Yeah, I'm not sure. It's not a very good answer.
It's okay.
It's not a good answer at all. It's a good question. Yeah, so okay, find me on the Rancher user Slack. I'm Adrian. It's pretty easy. Ping me there and I'll get you an answer.
Okay, rock on. Thanks, Adrian. All right, the next one is from Anthony, who says, can you explain load balancing a bit more? I thought you said that it requires an IaaS provider, but you seem to be doing it on a custom cluster, so I'm confused.
Yeah, no problem. There are different service types. Let's see. Yeah, this is actually, I'm going to do it this way. Come back over here. I'll come back to my slide deck. So if you deploy a service, I couldn't highlight that. if you deploy a service of type load balancer, remember there's a difference between services and ingresses. If you deploy a service of type load balancer and you are in a cloud provider or an IaaS provider, it's really hard to say, then it will create a load balancer in that cloud provider if it knows how to do that. I mean, you cannot give it credentials, obviously, it's not magic. So that's a service of type load balancer. With all the correct configuration, you're going to get an ELB or a Google load balancer or whatever. If you don't want to pay for that, or if you're running like I am, not in a cloud provider, then you create a service of type cluster IP and you create an ingress. An ingress uses what's called an ingress controller, and it's a software load balancer. By default, it's the Nginx ingress controller. There's also HA proxy, there's traffic, depending on what you want to use. The ingress controller opens port 80 on routing to the cluster IP service via the load balancing functionality present in Nginx or HA proxy or whatever. So that means that in the case of our ingress over here, yeah, so under the load balancing, see it says layer 7 ingress. So that's what I've created. So on my host over here, it's listening on port 80. Yeah, so that's the default backend. That maps through to the stuff inside the cluster. And then all I have to do is make sure that traffic lands on that host when I go to it in a browser, which is why we're using xip.io. In the other cluster, I was using training.cl.monoc.us because that's my inside domain.
Awesome. Thank you. The next one is from Scott, who asks, if you have Rancher installed like this, is it possible to access an API on it, such as Jenkins server, maybe kicking off a script to start a new deployment or to modify an existing one?
Yes. Everything that you are seeing in the Rancher server is actually talking to the Rancher API. We are 100% API driven. There is a CLI that you can pull down from here for whatever your platform is. It's just a single binary. Once you have this installed, come up here and come to API and keys and create an API key for yourself. And then whatever access you have inside of the Rancher cluster, you'll be able to use with that API key. So let me see. So we'll call this CLI, and I'll say create. And you see there's the API endpoint. If you're going to do it with a username and password, access key and secret key, there's those. If you're going to do it directly with an authorization header using the bearer token, then there's that. So for the Rancher CLI, you would take the token and you put it in your config. You can actually do, forget what it is, Rancher login, I think. Rancher login, yeah. So with Rancher login, you pass the token value, and then it's going to ask you questions about which server you want to connect to. Sorry, there's that. And once you're connected, it'll ask you what projects you want to use. You can switch back and forth later, but by default, it just needs to talk to a single project. And then you can do most of the stuff that we're doing here that's not kube control, but like you can create namespaces, you can control authorization, you can deploy apps from the catalog, which I didn't have time to show you guys today. You can do a lot of that stuff via CLI. The Jenkins example, though, you can actually do Rancher kubectl thing. Yeah. So if your Jenkins server only has a Rancher API key, you don't need a separate kube control config. You can just use that one API key and run Rancher kube control, and it will proxy all of the kube control stuff directly over.
Super cool. This next question, you might have actually just touched on it as it's related to Jenkins. So this is Aravind, who asks, does Rancher have API that it can use to call from a Jenkins job in order to deploy a new version of a Docker image, which would represent a new build of an application?
Yeah.
Created. So yeah. Go ahead.
Yeah. Oh, yeah. Yes. Sorry. Was there more to the question? I thought that was it.
Yeah. He just said, better yet, is there a native Jenkins plugin for Rancher?
There's not a native Jenkins plugin for Rancher. yeah, there's not a native Jenkins plugin for Rancher. So when you're deploying stuff, like you've seen me use the UI. Um, so come to defaults and catalog apps. So come to workloads. So so I deployed stuff with the UI, but I can, kubectl create, deploy Nginx image equals Nginx one what we were using. Let's use Nginx. And so I just created that with kube control, and you will see now under workloads that there's an Nginx deployment. So the deploying of workloads portion that you want to do from Jenkins, you can do with kube control. And to get, back to what I just showed a moment ago, you can run, you can make it easier by running Rancher kube control, create, deploy, whatever from your Jenkins job to create, destroy, do, whatever you want to do. You can spin up entire infrastructures inside of Amazon or Google and then deploy apps into them, run all of your tests against them, and then destroy them all from the comfort of Jenkins or whatever other CI/CD system you want to use.
That's awesome. Thank you. All right, let's do. Oh, this one is from Runal. It's asked the question a while ago and been waiting. It
Mhm.
is, if Rancher node is inactive, where do I look for the logs, and what could be the reason for it? When I do launch Kubectl from the Rancher UI, I do not see an inactive node. What's the best approach here?
When he launches kube control from the Rancher UI, he runs, I'm hoping, kube control get nodes. Here, let me run this over here because I have more than one node. Get nodes. So you see over here, I have my 3 Rancher nodes. We can actually do this screen a little larger. So I've got my 3 Rancher nodes and they all say ready. If one of them was not ready for whatever reason, the state and the reason of why it's not ready is stored in etcd. So etcd in this case, because I have 3 nodes, I'm running 3 etcd instances, and they are an etcd cluster. They have quorum, and one of them is the master, but data is replicated across them. So if for some reason I went and like shut down Rancher 03 right now, which I'm not going to do because, well, I'm not going to do it, but if I did, it would go into a not ready state, and I would be able to say kubectl describe, so KC describe node Rancher 03, and the reason why would be in here. It would say, here's conditions, or down in events or something. There would be some information here about why Kubernetes feels that that node is not ready. That information should also be visible at the cluster level under nodes. Yeah, so I only have a single node here. There we go. So it should say inactive, or it should have something here. And if you select it, it should give you information about why it's not responding.
Cool. Okay. Thank you. All right. The next one is from Jeff, who says, the default Helm installation includes notes on how to make your own cert store and generate a cert. Once you're happy with your kube environment, can you show how you can get rid of this Rancher cert store and begin using a signed certificate from a cert authority, for example?
The default Helm installation. Okay, so it's not the installation of Helm. It's the default Rancher installation uses a Rancher self-signed certificate. Let me jump out to our docs real quick. It's there. Rancher 2 installation. Let's just say single node install. And so here, so option A, default self-signed certificate. And he's interested in bring your own. So I have not done this, and What I'm about to say, I don't actually know if this will work, but it's the kind of thing that because Rancher is really easy to spin up and spin down, you could test it yourself. The upgrade process for Rancher, especially in a single node installation, is you basically just stop the previous server and start a new one pointed at the same data directory, and it does all of the stuff that it needs to do. So I would not be surprised if it's as easy as just stopping the existing Rancher server, make sure that you have your data in a persistent volume. So follow the upgrade procedure. Um, but when you do the upgrade essentially you're going to upgrade to the same version, add the SSL certificate data like you have here, and see if that maps your new certificate in on top of it. Since it's just an SSL certificate, it's not used by anything internally. And all of the downstream nodes will accept it because it's signed by a recognized CA. So I'm guessing it's going to be that simple. But I definitely recommend that you try it on a non-production Rancher server before you go and nuke your cluster.
Cool. Awesome. Thanks, Adrian. Okay, the next one is from Juiced, who asks, does Rancher 2 still include a load balancer like the one available in the version 1 series? That one
Yes.
was, okay, he says that one was useful for hosting multiple sites on a few hosts without any hassle.
Okay. So here's my production cluster. You can see that over here, I'm running a bunch of different stuff. I've got some Node-RED stuff for my home automation. I've got 2048 because my wife is really good at it and she loves it. I've got Plex. I've got some utility stuff, same thing, backups. But a lot of these things have like Logstash. These have web interface endpoints. They're web applications. So over here under load balancing, I've configured the various ingress rules. And these represent rules. So in fact, that app no longer exists. But let's look at the home automation, my Node-RED for Home Assistant. If I come and I edit this, you'll see that I'm using a specific hostname, dashboard.cl.monoc.us, and I'm mapping slash to a particular service on the backend. All of these things are going into the Nginx ingress controller configuration, and there's one instance of Nginx that's running on each of my nodes, and all of these rules are load balancing routing rules. So all you have to do is deploy Rancher 2, set up your workloads. This is the corresponding workload here. I edit this. You see I'm publishing a port through as cluster IP, so that creates the service. And then in the load balancing config for the same thing, I added the ingress and I pointed it at the service on the port that I just designated. And it just works. It is load balancing. If you don't like the Nginx ingress controller for whatever reason, that's what we ship with by default. You can install HA proxy or traffic or any other ingress controller that you prefer.
Sweet. Awesome. Thank you. Okay, next one. This is from Diego, who says, how would you recommend an HA Rancher install, and which OS would you use? Rancher OS, maybe?
Rancher OS is cool. For those of you who don't know about Rancher OS, it's a super, super small operating system that runs everything as Docker containers, including all system services. And thus, it only runs what it needs to run Docker container workloads. It has a very small attack surface and a very small footprint. It's very popular with our users who use VMware. It's just super light and super fast. But Rancher will run on anything that runs a supported version of Docker. I myself don't use Rancher OS because I like to log into my machines and actually do stuff. I like to do the initial provisioning and updates with Ansible and so on and so forth. So I prefer Ubuntu. We have a lot of people running Red Hat or CentOS or Fedora. We don't really run into obscure things like Mint or Arch or whatever, but it's going to work just fine as long as it runs a supported version of Docker. As far as how to do the installation, go to our docs, come down here to installation, select high availability install, and this will walk you through how to do an HA install, which will use RKE. RKE is our super fast Kubernetes installer. This thing makes it really easy to stand Kubernetes clusters up, to modify them, to tear down nodes, to reconfigure them, to do whatever you want. So what you'll get here is a full installation of RKE. So you need at least 3 nodes. This guide will install RKE onto those nodes, and then we'll install Rancher via Helm into that cluster. The HA component is delivered by etcd. And so in order to have Rancher be HA, it's not like in version 1 where you just needed 2 Rancher servers and they talked to each other and they did all this stuff. You actually need an HA Kubernetes installation. So the only supported format for that is using RKE because it's ours, so we know it and we can trust it. Theoretically, you could install it into another HA Kubernetes installation, but because we don't know anything about that cluster, that is not a supported configuration. But once you have Kubernetes, you just install it via Helm. Here's the steps. It'll take you about 6.5 minutes, and you'll be done.
Sweet. Awesome. Okay, here's another one. This is from Diego. Let's see if I can get these acronyms right. He says, can I use ISCSI with LVM on var lib docker to increase my storage for containers in case it runs out?
You use iSCSI with LVM. Okay. Well, the short answer is yes. So I understand your problem is that you have varlib docker and space runs out. So you want to use LVM so that you can grow it as you need to. Cool. You have some backing store that is iSCSI based. So what you're going to end up with is iSCSI is going to be your physical volume. So it's going to be your PV. And you'll have, whatever, you'll mount a disk onto the host and it's of X size, and that's the only thing in your PV. And then when you run out of space, you're going to attach another iSCSI disk to it. Or if your backing storage provider allows you to grow your iSCSI volume, you can just grow it. Most of them do. So you would just grow your volume, and then you would grow the file system and the logical volume on top of it. So yes, essentially you can. That's how I would architect it. I run iSCSI here in my house. My primary storage is a Synology NAS. Actually, I have 2 of them. And so all of my virtual machines run on iSCSI storage with LVM on top of it in Proxmox. And then all of my shared storage runs off of NFS, off of a different Synology NAS. I told you I'm a super nerd.
That's so awesome. Yes. It's so cool. Synthetic. Okay. Here's another one. This says, if a pod or a service which is containerized needs to talk to a traditional non-containerized database such as Oracle, then does Rancher 2 provide built-in service discovery, where, for example, new pods can look for the database service?
Well, if you're running anything outside of your cluster, then presumably it has its own DNS name. It's got a host name, it's got an IP address, it's got some stuff. And so anything that can find it, no matter if it's a pod running inside of the cluster or if it's a host or virtual machine or something running outside of the cluster. As long as you can do DNS resolution of a host name, or as long as the IP is reachable, then everything can find it. However, I will take this opportunity to show you something cool that we do. Come to the other cluster, which is here under service discovery. So I'm in the default project on the new cluster that we just built. And under service discovery, it's created some stuff for us already. But I want to create something new. So imagine a slightly different scenario. Imagine that you're running MySQL, Postgres, Mongo. Mongo is a good example. Mongo runs well inside of Kubernetes as a stateful set. So imagine you've got Mongo running outside and you plan to move it into the Kubernetes cluster. And so as part of that process, you want your workloads inside of the cluster to be able to talk to an inside the cluster service so that they just get in the habit of talking to that service. And right now, that service points to your Mongo cluster outside. But at some point, you're going to move the Mongo cluster in, and you don't want to have to reconfigure all of your workloads. Well, in that case, call this Mongo, you're going to create a service record that points to an external hostname. And it'll be mongo.mydomain.com or something, or any of these other things that you see here. So an external IP address or an external hostname, depending on how you have it. You can do DNS aliasing. And so when you create this, just hit create. Now, inside of the cluster, we have a service called Mongo. And all of my things inside of the cluster can just talk to Mongo, and Kubernetes will handle routing that out to wherever it needs to go or in to wherever it needs to go once it moves. When it moves inside, we just repoint the service.
Awesome. Cool. Awesome. All right. The next one is also from Arvin. It says, does Rancher 2 have built-in like private Docker container registry?
No, Rancher 2 is not a container registry. We will talk to any container registry. The way that you would configure that is up here under resources, you would set registries. And so I, for example, run GitLab. So I would say that it's a custom registry and it's out at git.knock.us, and I would give my username and password, and then I would say save. And I didn't want that. Call it GitLab. And I would say save. And now when I deploy images that reference git.monakas as the origin of the image, Rancher knows how to go and log in and pull that image. You can do that for any registry, Artifactory, Quay, Harbor, whoever, doesn't matter. As long as it speaks the Docker registry protocol, we'll talk to it.
Cool. Awesome. All right. Here's another one. Kind of a longer question. If a secret needs to be in an application properties file inside the container that this Dockerized application reads, then can we at container instantiation time inject a file into that container using a config map?
Yes. So the catch is if you have a configuration file and the secret needs to be inside of it, there's no magical way to stuff a value into a space in a config file. You'll have to do that yourself. But the way that I've approached that, if that's what you need, is I'll map the secret in as an environment variable, and then my container init process will extract that environment variable, and using sed or something will swap the value into the config. But if what you're looking for is just how to make an entire config, then I present to you my Borgmatic container that I just built a couple of days ago. So Borgmatic is a configuration utility and an automatic runtime thing for the Borg backup engine. And I decided I wanted to run it inside of Kubernetes to get a backup of stuff that's on my NFS server that's dynamically created by containers, whatever. So I built a Borgmatic config and a Borgmatic. So in the Borgmatic config, it's just ugly if we look at it out, looking this way. Now we're not talking about secrets here. These are just config. So I have two keys, config.yaml and exclude. And then this is literally the full Borgmatic config. And then this is mapped in as the exclude. And I want these to be generated as files inside of the container that launches. So the way that I do that is in the Borgmatic job itself, under volumes, I said that, let's see, data is my NFS share. Okay, so config is a config map, and I'm using the config map called Borgmatic config, and I'm mounting it at etc Borgmatic. And what ends up happening is it will take all keys. Remember, one key was called config.yaml, and the other key was called exclude, and it will create files with those names. So it'll create a file called config.yaml, the contents of which are the value of the config.yaml key. There's my whole config. And then it creates an exclude that the contents of which are the exclude key. And there's my whole excludes file. The cool thing about config maps is that when you update them, if you have a running container, Kubernetes automatically updates them inside of the container. It won't restart processes, but if your container is intelligent enough, the process is intelligent enough to figure out that there was a change and reload the config. And some things are, like Logstash, for example, it allows you to update running containers without having to kick them. As far as secrets, Borgmatic needs SSH. So I have a secret that has an SSH private key in it, and that is stored encrypted inside of the Rancher Kubernetes etcd data store. It gets mounted same way as files. So there's two keys in there. There's private key and a public key. And it gets mounted as optborg ssh slash idrsa or idrsa.pub. And then when I run Borgmatic, I tell it, look in that directory for the SSH keys. So each of those represent the same thing. You create files from either config maps or from secrets, and then you reference those files. If, however, you want your secret to be, so let's use a secret. And so we'll pick a secret. We'll call it, whatever, Borg repo key. Oh, in fact, I actually have that here. Delete this. Move volume. I have Borg repo key up here as an environment variable. So this is the passphrase for Borg to log into its encrypted repository where it makes its backups. So I have a secret called Borg repo key, and the key in there is Borg passphrase, and it will get attached as the environment variable Borg passphrase, which is what Borg looks for when it goes to actually run its backups. So if you this goes back to what I said in the beginning, where you can mount secrets in as an environment variable, and then your application just has to be smart enough to either use it or to extract it and put it in a config file for the application to use.
Sweet. Okay. So actually, on that note of secret management, the next question is about secrets. And just so you know, Adrian, we are coming toward the end of the list of questions so far.
Oh, I'm so sad.
I know. All right. So here's the question. For secrets management or environment-specific credentials, would we use a combination of config maps and Rancher secrets? Does Rancher support integration with other secrets providers such as HashiCorp Vault?
The HashiCorp Vault question. I'm not up to date on what we're doing with Vault. So let me show you how we can approach this. So we've got secrets. So you can create a secret over here, and you can call it whatever. Let me jump to the other cluster so I'm not screwing around with my production cluster here. Secrets, add secret. We'll call this training secret. It's available to a single namespace, whatever. My key, my secret value. Let's just say. So with a secret created, you can use it in any of the ways that I showed in the previous question. So I won't go through all of those again. As far as integrating with HashiCorp Vault, I'm not gonna answer that. I'm gonna ask you to ping me on Rancher Slack because I need to go back to engineering and find out what the current state of that is. We used to have an integration. I don't know if we're now offloading that to Kubernetes or if there's some, so in 1.6, you could tell it that it was using HashiCorp Vault for secret storage, and I don't know what that maps to in 2.0. So I can get that answer for you, and I don't want to give an answer here that's not correct, especially since this is being recorded.
Awesome. Okay, great. So there's two more questions that are on our queue. This one's from Runal, who says, let's say there's a Rancher core server HA with 5 node clusters in AWS and behind an ALB. What is your suggestion on backup and restore?
Backups are an excellent topic. Where's my documentation? My documentation is here. Okay, so how many nodes are in his Rancher server? It's an HA cluster, you said, right? And there's a 5-node cluster behind it?
Yeah.
All right. Everything about Kubernetes is stored in etcd, period. So as long as you have a backup of etcd, then you can restore your Kubernetes cluster anywhere. So for the HA Rancher installation, that's running on top of Kubernetes and it's using etcd. So if you come out here to the installation guide, you come down here to backups and disaster recovery, then we talk about how to perform a backup of NHA. And basically what this comes down to is you mount some sort of shared storage on your nodes at a specific location that gets mounted into the etcd containers. And there's a job that runs every whatever interval you tell it to that dumps etcd on all of them and dumps them to that shared storage. So you end up with a backup of etcd at whatever interval you want. I recommend that you pick an interval that is the lowest interval that you can survive data loss. So like once an hour with retention of 24 hours or something, whatever's appropriate for you. You can also secondarily back up that shared storage to an offsite location, which is smart because doing backups to the same location, like if Amazon burns to the ground, you're still in trouble. As far as the Kubernetes cluster, same thing. You would need to back up etcd. If it's RKE, then great. You can come out here to the RKE docs and we talk about how to do backups as well. If it is something else, then you're gonna have to figure out how to back up etcd for that something else, which leaves you with the data. None of this backs up the data itself. So if you have applications that are backing up data, then there are lots of solutions that you can use to back up data, depending on where it's located. Application with S3 or stuff. But if you are interested in an internal Kubernetes backup solution for backing up shared storage, look at the Borgmatic container that I just was showing. It's my cluster again. Too many tabs named Rancher. I'm gonna close that tab. So if you look at go to here, it's just up as Monakas Borgmatic on GitHub as well. This will talk to you about, doesn't talk to you about the Kubernetes part, but it'll talk to you about how to deploy Borgmatic. And I'm going to have an article up for Rancher's blog sometime in the next, I don't want to pin myself to something, sometime in the near future about how to deploy this inside of Kubernetes to back up any data that you need backed up from inside the cluster.
Cool.
Matthew, still there?
Yeah. Cool. I didn't realize you were finished. Okay.
I'm done.
All right. Wonderful. Let's go to the next one. Is there a specific storage driver, such as BTRFS, that Rancher works well with, or is that delegated to Docker to manage?
Yeah, there's not a particular storage driver that Rancher works well with because ultimately the Rancher server doesn't really care about storage. It just doesn't care. So BTRFS is a file system that if you're running on something that uses BTRFS, then great. If you're not, then great. I mean, you can be running on ext4, you can be running on, if anybody's still running on Riser, like it doesn't really matter. However, as far as, I'm going to answer a question that you didn't really ask, which is as far as storage itself, I just want to show that any backing storage that Kubernetes supports, you can use via Rancher in your Kubernetes deployments. So here's a big list of everything, including our own Longhorn, which is still experimental. But all of these things are supported by Kubernetes, so you can deploy workloads that utilize them. You can provision EBS disks, you can mount NFS, you've got Gluster, whatever. We'll happily talk to it.
Cool. Okay. The next one's interesting. It says, is Rancher server free to use for enterprise use? And if so, what's the price? What's the pricing information on the Rancher homepage for, Ben?
Rancher and all of everything that Rancher produces is 100% free and open source. 100%. There's no community edition with crippled features. There's no enterprise version for whatever. Everything we make is 100% there for you to use. If you have the technical skills to support your cluster yourself, great. Do it. Run it. We have thousands upon thousands of deployments out there, and all of them are working well. The pricing information on our page is because there are some businesses who would like additional support. So for that reason, we provide support contracts. If you want to make sure that if anything happens to your cluster for any reason, not just with the Rancher components, but with the Docker engine or with anything in Kubernetes, you have somebody to call, you can get a support contract from us. We do root cause analysis. We will help you with architecture, with provisioning. We do training. We do support. If you just want to ask us questions because you're planning an upgrade and you want to know the best way to do something so it doesn't bite you, then like all of that stuff is available if you want. But if you don't want any of those things, you can still use the product for free.
Amazing. Um, and so I think the next question will be our last on the queue anyway, and it is very related. Um, for enterprise level installations, what are the top 5 features of Rancher compared to OpenShift?
OpenShift. um, I can't give you a competitive analysis between Rancher and OpenShift. I can tell you that Rancher uses, so and we're a free and open source product. We use the upstream open source version of Kubernetes. We work with Kubernetes that runs anywhere. So if you want to use Kubernetes in Google, Kubernetes in Amazon, if you want to cluster in both, if you want to cluster in your house, if you want to cluster on your dog, it doesn't matter. Any Kubernetes anywhere that we can talk to, we can manage. The best enterprise feature that I can tell you we have is the centralized role-based access control. When you come out here and you configure it to talk to Active Directory or GitHub or whatever, and then you start setting policies and roles, and then you can apply those things to all of your clusters, suddenly you're free because your developers can have the freedom to go and spin up Google clusters or Amazon clusters or clusters wherever they want, and you can still manage those clusters and make sure that certain people can't do certain things, that they can't see clusters running somewhere else. And you know that everything that you're getting is 100% upstream Kubernetes if it's RKE, or it's whatever you're running on Google or Amazon or whatever. If at some point in the future you decided that, you know what, Rancher's not for me, I don't want to use it anymore, you just turn off the server and you can still manage all of those clusters directly using their local authentication with kube control. So there's no lock-in. There's no, oh, I got to disentangle from whatever. It's free, it's open source, it's upstream Kubernetes, and we're not going to tell you what you can and cannot do. If you want to use us, then great. If you want to stop using us, then great. Other vendors out there have a different viewpoint. Other vendors want to tell you what you can and cannot do. They've taken Kubernetes and they've changed it to make it into their flavor of Kubernetes, and then they charge you a really fat licensing fee on top of it, and all of that promotes vendor lock-in. Vendor lock-in is, I don't know if it's the number one thing we want to avoid. We mostly just want Kubernetes anywhere, but we want to make sure that you have the freedom to do the things that are the best for you today, tomorrow, next week, wherever. We don't want to get in the way of that. We want you to use our product because it makes your life easier, not because we have a gun to your head.
Amen. All right, rock on. Well done, Adrian. I'm gonna get out of
Yeah,
my
you can tell I
chair
don't have
and
any strong
holler
feelings about that
around.
at all.
That's right. That's right. Speak it, brother. So that was the last question. I'm gonna go ahead and switch presenters back
All
to
right.
myself just to close out these last couple slides. And thank you, thank you, thank you. You rocked it. Let me make sure I get the right screen. Okay. Can you see this closing slide?
Yep, I see it.
Amazing. Okay, well, everybody who's still on, thank you so much for joining us. And we want to, keep the conversation going. If you want to, please join slack.rancher.io. Many other participants from the training are already there, and this conversation can continue. And like I said at the beginning of the training, we thrive on your feedback. We make these trainings, more responsive to what you're actually interested in and what you need to know. So if you can take a couple minutes to fill out the survey at the end, it would be super helpful. And obviously everybody, from the trainings forward would benefit. And if you want to give us a shout out on Twitter, you can use the hashtag Rancher Training. And you can just give a shout out to Adrian for doing an amazing job on Slack. His handle is just Adrian. So well done. Thanks, everybody. And we'll see you next time.
Thanks, everyone. Take care.